In this discussion, I had the pleasure of speaking with Dr. Kolvoord. Dr. Kolvoord is a Geographic Information Systems professor and the Dean of the College of Integrated Science and Engineering at James Madison University. In this discussion, I asked Dr. Kolvoord questions regarding his experience, research, and teachings in geographic information systems, geospatial tools, maps, Saturn's F-ring, NASA's Cassini Mission, 3D and visual models, sustaining humanity, and much more. I hope you enjoyed this discussion as much as I did. Feel free to provide constructive feedback. Thank you for tuning into the Common Human Podcast. Seek knowledge and wisdom always. Dr. Kolvoord, you know yourself better than anyone else, better than me, your coworkers, your neighbors. Could you describe who Dr. Kolvoord is while touching on your educational experience in 20 plus years as a professor in integrated science and technology program at James Madison University?
Oh, sure. That's an interesting question. Sort of introduce myself to myself. I am a serially curious fellow. I find myself interested in lots and lots of things, and that has led to a really interesting career path for me. It has taken me from originally being interested in physics, and my bachelor's degree is from the University of Virginia in physics. I moved into material science for a little bit and got a master's degree in that. And then I decided that I needed to get out of UVA. I had been there for a while. And I moved up to Cornell, and I got involved in this really interesting discipline in engineering called theoretical and applied mechanics. And we used to joke that it was where everybody at Cornell that liked engineering and was good at math ended up.
Right.
And what I studied there actually was the dynamics of Saturn's rings.
Mm-hmm.
And so I got to understand this really interesting, very thin ring right on the outskirts of the main rings that we're familiar with called the F-ring, and figured out how it worked and what caused the F-ring's really interesting because it looks in places like it's kinked or it's braided.
Mm-hmm.
And so was able to do some work to help explain that. And one of the coolest things in my career actually was I had found evidence that there was a small satellite embedded in that ring, but
Okay.
the imagery wasn't good enough to pin it down. And about 15 years later, the Cassini spacecraft went back to Saturn. I was working with data from the Voyager spacecraft, and it actually found that satellite.
Interesting.
And my advisor at the time emailed me and let me know, and that was pretty cool.
Successful research right there.
Yeah, and just it's one of those things that you don't know in the moment, right?
Mm-hmm.
It's not until people are doing other work, and that's really been at the heart, is that I've very much seen myself as someone who's parts of teams, who collaborates, never been kind of a lone ranger.
Sure.
I ended up actually at the University of Arizona for a little bit, where I got to introduce myself at parties by saying I build planets. I was studying how planets actually form. But I realized that was really not where my passions lay. And I got involved in a teacher education program out there that was teaching teachers how to use digital imagery to teach science and math.
Okay.
And I got really fascinated by that. I really got into it, and have really I sort of pivoted, if I'll use an overused word. And I've spent most of the last 35 years helping teachers use technology in their classrooms.
Sure.
Digital kinds of technologies. And along the way, got involved in some entrepreneurial things. We started a couple of companies out of that work at the University of Arizona. And then after I'd done it for a little while, I thought, I'd be much more credible giving these workshops if I had my own classroom.
Absolutely.
But I was really drawn to innovation and startup kinds of things. And so I'm in Tucson, Arizona, and I'm looking out across the country for what was the most interesting thing going on.
Mm-hmm.
And it was the Integrated Science and Technology program at JMU. It
Right.
was in its infancy at that point. And so I applied for a job, and I was fortunate enough to get hired. I got hired in 1995.
Wow.
And so I'm going to be 30 years at JMU.
That's amazing. Congratulations.
Well, thanks. And the ISAT program really lived up to its billing. We were really forced to think about how you might provide a science and technology education in a very different way.
Sure.
And it was this really cool coming together of people from all these different disciplinary backgrounds that were working together to create this new and different thing. And I think we managed okay. ISAT celebrates 30 years this year.
Mm-hmm.
We have thousands of grads that are out there doing really interesting work across a wide variety of things. I just came across one who has become a judge, ended up
Oh,
going to
wow.
law school, and is
Interesting.
part of the judiciary in Virginia.
Okay.
We've had folks work at Tesla and work at Google and all of the big tech firms. And we've had people become teachers
Mm-hmm.
and professors.
Mm-hmm.
And so it's really been a fascinating place to spend a career. And over time, I found myself with some interest in administration. So for a little while, I led our engineering program
Sure.
when it was just starting up. And then 12 years ago, I became the founding dean of the College of Integrated Science and Engineering. And that's the job that I'm in today and the chair I'm sitting in as I'm talking to you.
Beautiful.
But
Beautiful.
the thematic thread here, I guess, is I really like to ask questions. I want to know why, and I don't feel like I should be bound by these artificial boundaries we call disciplines.
Sure. No, I think that's a great point. And just to touch on your original point of, I mean, you talk about Saturn's F-ring, and we'll get to that in just a second, but the conversation of potential discoveries and not necessarily knowing what's out there until you do the research and you do the work. And then as well as touching on ISAT and the program at James Madison University. I mean, I was a finance major, but I do know, and I had friends that were on East Campus within ISAT as well, and just an incredible program. So to be a part of that is truly amazing.
It's been a privilege to be a part of it. I really feel fortunate.
Yeah, yes, sir. So one of your main research interests is geographic information systems. So could you describe what the study of geographic information systems is all about, and how your interest in this topic originated?
Yeah, GIS is a fascinating technology, and it's one of those technologies in our world that's kind of hidden in plain sight. It's literally all around you, but until you know to look for it, you just don't pay any attention to it.
Mm-hmm.
So GIS is all about maps connected to databases. As humans, we've been using maps for thousands of years to give us directions and to tell our stories. And what GIS is oh, all right, sorry, I'm in a grammatical cul-de-sac there.
No, you're fine.
GIS is simply a way to do that using computer technology.
Okay.
So the idea is that you can make maps on computers, but those maps could contain thousands or tens of thousands of data points. So I'll give you, for instance, we just had class last night, and my students were working with a database of tornadoes that had hit the U.S. in the last 22 years. And across the U.S., that's tens of thousands of tornadoes.
Right.
And so it kind of combines big data with this interface that we're really familiar with, right? We learn about maps from the time we're really, really young. And I will say my interest in GIS, I think, has been catalyzed and energized by the fact that I'm a map geek. And in fact, if you look behind me, you will see
There it is.
actually an antique map.
Okay.
But I am completely fascinated by all of the different things you can study using maps,
Right.
whether it's demographics and looking at equity gaps, whether it's looking at pollution, whether it's looking at urban heat islands.
Right.
So many of the things that we do are geographic. And oh, by the way, anything that has to do with location on your phone, which many things have to do with location on your phone,
Exactly.
it's all GIS.
Mm-hmm.
So it's right there in front of us, but yet until you kind of peel back the layers, you don't know what it is.
Right. And you never, like you just said, you never truly understand that it's around until you potentially investigate. And you speak of also incredible points. I mean, my initial research on this was, I truly never understood the discipline of GIS in itself, but it explains so much in which you say equity gaps and tornado heat maps and weather in particular areas. So you feel as if it's been truly beneficial for one, professing and educating other individuals, but your understanding of the world.
I absolutely. And in fact, one of the things that we've done, and we've done it for almost 20 years now, is we've brought GIS to high school students in Virginia, and we run a project called the Geospatial Semester.
Hmm.
that we started back in 2005, and where high school students are able to learn about this technology in their schools, and they earn JMU dual enrollment credit for it.
Sure.
And what that's done is it's opened gateways for these high school students that would have never stumbled into geography otherwise. I
Right.
mean, geography is one of those lost subjects in K-12. If you had it, it was largely, well, can you memorize the capitals and the states,
Hmm.
mountains, which is just the most boring part of geography, right? The cool
Right.
thing about geography is you get to ask why things are where they are,
Hmm. And
and
there's so much,
what
yeah,
has caused that to happen? And that's a really powerful question.
yeah, absolutely. And there's so much intertwined within everything. Like when you look at these original maps, you're just like, okay, this is the layer of the land, but then there's development on that land, and then how does that development progress over the years? And then you see, okay, that development over the years, is that detrimental to this particular area in Virginia or obviously across the world, right? And then that comes into the conversation of climate and all of these things. So you mentioned geospatial tools. So what are geospatial tools, and kind of what are their applications in GIS in this particular setting?
Yeah, this is one of those places where the vocabulary gets a little bit confusing.
Okay.
So the big umbrella here is geospatial technology, and there are, depending upon who you talk to, I mean, we can get into arguments about this, but
Sure.
for the purposes of the podcast, there are three primary geospatial technologies that we'll
Okay.
talk about. One is GPS. So that's this set of satellites that are above our heads that allow us to get our positions really, really accurately.
Hmm.
And that enables so much of what we do on the phones,
Right.
because that all is based on the fact that you can get your location to within 10, 15, 20 feet.
Sure.
So that's one class of geospatial technologies. A second one is remote sensing, and that's the imagery that's taken by the satellites, a different set of satellites that are overhead that
Okay.
give us those really high resolution aerial images.
Hmm.
Where, anybody that's ever gotten on Google Earth, the first
I
thing they
was
do
just gonna
is
say, like
go to the
Google Maps,
warehouse,
Google Earth. Yeah. Okay.
and
It's like the
that's
red car. Oh, I was
yep,
like, I had that red car 5 years ago,
exactly
but
right.
it's not. Yeah.
And that's a remote sensing image.
Okay.
Now, the interesting thing is that we can sense in a bunch of different wavelengths. So our eyes sense in a really narrow part of the electromagnetic spectrum, right?
Hmm.
Compared to what's out there, we're we're not seeing very much. But the
Sure.
satellites can look in the infrared, they can look in the ultraviolet. So this lets us do things like assess crop health,
Okay.
imagery of fields. It lets us look at how much impermeable surface there is in a city, stuff that's
Sure.
asphalt or concrete or that sort of thing. So that's a really rich data set. And then GIS is the software that kind of brings those pieces together and lets you analyze both the data from the satellites, data that humans generate that have some sort of geographical position.
Okay.
Uh, a big push behind GIS, interestingly, and this is a part that doesn't get nearly as much attention, is a lot of the push behind GIS was to actually get accurate tax maps.
Hmm.
Accurate, they're called cadasters,
Okay.
because so much of our, the way our society works is built on land ownership,
Right.
and actually having accurate records of land ownership, land transfer. So there's a large piece of the GIS world that's focused on doing that sort of work. So it's often municipal, sometimes state governments
Okay.
that keep very close track. So Lucas, where do you live? You live in
I
Richmond?
live in Richmond, Virginia. Yes,
So
sir.
in Henrico County, if they're going to build a new housing development, right, that was originally one piece of land.
Okay.
But once they start to build houses, that's going to become 20, 30, 50.
Exactly.
Well, how do you keep track of that? And
Hmm.
then who actually has the data of record to know where your property line is, and so
Right.
you know that you've built on your lot and not on your
Okay.
neighbor's lot.
Okay.
That's also all GIS.
Understood. So it's
So
okay.
again, hidden in plain sight. This is something that we all rely on, but nobody thinks about it.
Right. Without making sense of all this data from GIS and then these satellites as well. And so just so I understand, you say, so you get information from, like you said, we only have a specific perimeter in which we can see as humans, right? And then we'll get specific data from our phone, and then these satellites, like through Google Earth and these different images they're creating for us, that allows us to understand. And then through infrared imaging or different, changing of the colors and sensing, we can understand different data within just our everyday life.
Yeah, that's exactly right. And
Okay.
humans can collect data. So one of the cool things of these devices is it makes all of us potentially a scientist.
Right.
So for instance, there are some cities
Potentially,
that
that's
have
okay.
apps where citizens, if they see graffiti or if they see a street lamp that's out, they can record it, transmit that data to the city managers,
Sure.
and then that it has to somehow go from data collected by the citizen into a workflow process that actually sends somebody out to change the light bulb.
Right. Right.
And so that's
It's like a natural
driven
progression
by
of.
the GIS because you have the geographic, you know where that light bulb is out.
Mm-hmm.
And now you have the efficiency of, you don't have to have somebody run around town looking for light bulbs that are out. The citizens are going to report it, and then you just need to fix them.
Okay.
So
So,
it's kind of an interesting way. There's a way in which it democratizes the access to data. So it used to be that you had to be kind of an expert to be able to get into this. And as a consequence, that sets up barriers, right? If
mm-hmm.
you're not an expert, then you can't
Can't
touch it.
access
And
the
if the
data.
expert's
Yeah.
not interested in what you're doing, well, too bad. Now there's a tool set where all of us can access GIS data. Many cities, many states, the federal government put a ton of data out there, all of the census data,
Mm-hmm.
data on the land records, data on
Like ozone levels, like you were.
ozone levels,
Yeah.
school performance. One of the things maybe we'll talk a little bit more about the geospatial semester in a bit. One of the things that our high school students there really enjoy creating GISs of are their athletic events.
Mm-hmm.
They will actually on the field plot out where the different plays are. So volleyball, say, all of the places that the opposing team was hitting, who
Okay.
made successful blocks, where the
That's always
assists
so
were,
cool.
all of that. The analytics that's in professional sports, all of that's
Yeah.
location based, right?
Yeah, exactly.
It's Major League Baseball playoff time.
Right. Where are they hitting within the square?
In the square, and where's that ball going in the field?
Mm-hmm. So amazing. I love how you're breaking this down because I didn't even think about it in a sports sense, because you can see heat maps on an NBA floor in which, okay, Stephen Curry, Golden State Warriors, where was he shooting? And then obviously it's all around, you see all the dots around the 3-point line and barely in the paint or whatever, like they call it. But yeah, that's absolutely interesting. And you just touched on a great point in which it's kind of a good transition in which, how does one make those spatial decisions? And, in an educational context, what geospatial tools do you equip your students with for success after graduation?
That's a great question. Let me start with the high school students, and then we can transition to what we do with the college students.
Sure.
For the high school students, we really want them to understand that there are questions that are spatial in nature, and that there are tools that you can ask and answer those questions.
Mm-hmm.
So they are required to do a final project for this course, and they're required to present that project in front of, often it's me or my colleagues that work on this. And we don't ask them technical details about the software.
Right.
It's if you watched me do this all day, you would see 1% of the questions are technical detail questions.
Okay.
The other 99% of the questions are, what do you think this means?
Mm-hmm.
Why did you do that? If you were going to extend this, what else would you do?
Sure.
Really trying to build within them this idea that, there's a line of inquiry here. There's a
Absolutely.
tool set of inquiry, and how can you use this across a variety of projects? And the great thing about working with high school students is they're interested in everything.
Mm-hmm.
And so if you look at, and we've done some research to actually categorize what they're interested in the environment.
Right.
They're interested in what's going on in their local areas.
Sure.
They're interested in alternative energy. They're interested in equality. I mean, we've
Mm-hmm.
had folks do projects on food deserts in Virginia, say.
Okay.
They're interested in healthcare. They're interested in social justice. And so it shows the versatility of the technology, and it really opens their eyes to possibilities. And the whole reason we developed this was in part to help them get ready for life after high school, whether they're going to
Right.
work, whether they're going into the military, whether they're
Mm-hmm.
going to college. And so it was never meant to be the GIS 1 class.
Absolutely.
Now, for our college students, and particularly the ones that major, so at JMU, we have a major called geography.
Mm-hmm.
And within that, there's a concentration called applied GIS.
Okay.
And there, we're really helping students develop the skill set that they can be professionals in this area.
Mm-hmm.
So we really do have a GIS 1 class,
Yeah. Yeah.
GIS
Exactly.
2 class.
It creates a groundwork to.
And we're helping them to understand, the technology underneath GIS, some of the computing aspects. One of the cool things, and this lines up with what's happening in a lot of the rest of the world of technology, is so much of it now is cloud-based. It's all done via the internet.
Mm-hmm.
And so showing students how to go from what they're used to doing on a desktop machine and say, well, you could do this anywhere with any device
Absolutely.
now. So it's really a nice, it's a fully fledged kind of education in the technology. We cover remote sensing, we cover GPS.
Right.
And then I teach an advanced class there that's actually an advanced spatial thinking class,
Mm-hmm.
where we're helping students really work with statistics and other kinds of qualitative tools that let them go a lot deeper than just identifying colored patterns on a map just by
Yeah.
looking
It,
at it.
right. Understood. And I love how you utilize the, like you explained with the high school students, the versatility in which they're thinking about like a variety of things, but you're also asking broader questions. It's not necessarily, I mean, it's important to understand the quantitative data and all the ebbs and flows and details, but it's the broader inquiries, like you mentioned. And then you talk about, within college, creating that subtle groundwork for, you said Geography 1, and then going deeper into technologies and other things within more advanced courses in GIS. Do you feel as if those have kind of helped students for their transition after graduation?
They absolutely have. And we have students working in a variety of GIS focused jobs, both within the government. A number of our grads work for the National Geospatial Intelligence Agency.
Right.
We have folks that work for ESRI, which is it's kind of the Microsoft in this world, the leading
Okay.
software developer. And then folks that work at city and local governments
Yeah.
around Virginia and beyond. So I think we've got a pretty good mix. And interestingly, JMU is one of the largest geography programs in the eastern half of the U.S.
Wow.
And I
I
think
didn't
some
know
of
that.
that is driven by this interest that we've sparked in high school. Between 15 and 20% of JMU geography majors participated in the high school dual enrollment class.
Wow. Okay. So what high schools are you typically targeting? Is it mostly Virginia schools? Or?
Yeah, it's
Okay.
almost entirely Virginia schools. Yeah, it's kind of hard to do this outside the state because
That
we
makes
regularly
sense.
visit the schools and we support the teachers and the students as they're doing the work.
Okay. Understood.
So a lot in Northern Virginia, but around the state. Actually, in your area, Henrico, and then also Stafford County has been really involved with us over the last.
Okay. Amazing. So Northern Virginia, Richmond area.
Yep.
Awesome. So switching gears just a bit, and you already mentioned kind of this Saturn-like research and all of this, which is incredibly interesting. So you've done incredible work in research for NASA Planetary Geosciences. Could you provide insight into what embedded moonlets are and their relation to Saturn's rings?
You bet. So the big question, so Saturn's rings we think are very young. We don't think they date back to when Saturn formed. And so the question is, how did they form? How do they evolve? And what we think happened is that there were moons that were around Saturn that broke up.
Mm-hmm.
And eventually that the debris from that breakup gets ground into smaller and smaller pieces,
Okay.
and it starts to spread out. Gravity spreads it out around Saturn, and you see this beautiful pattern of rings that we see.
Sure.
But not every piece gets ground down, and so you have larger chunks. And anything that has mass has gravity.
Mm-hmm.
And so if you've got a large chunk amidst a bunch of smaller pieces, it actually its gravity impacts those smaller pieces.
Right.
And so in the case of Saturn's rings, there are two moons. Wow, you're really making me dredge into the memory banks. I haven't thought about this for a while.
You're doing
There
great.
are two moons, Pandora and Prometheus.
Okay.
They bound the ring, and they're called shepherd moons
Okay.
because they keep the ring narrow.
Right.
And so it's like sheepdogs herding a bunch of sheep.
Sure.
They, by their position inside and outside of the ring, keep it narrow. And then smaller than that, but bigger than the ice and dust that's in there,
Yeah.
are what are called embedded moonlets. So they're chunks of stuff,
Okay.
mostly ice, that are a little bit bigger, and they kind of create wakes, right? So as they move, their gravity creates wakes, and then we can also see these braided or kinked patterns.
Okay, understood. So the embedded moonlets are basically the debris and ice that's within
It's
space.
bigger chunks.
Okay, bigger chunks. Okay,
Bigger chunks.
Understood. And then these, you said Pandora and what else?
Prometheus.
Okay, so they're creating almost discipline, I guess, within the...
Yeah, exactly right.
Okay.
Gravitational discipline.
Okay,
Yep.
Understood.
It's a nice term for it, actually.
Okay, beautiful. So a member of the imaging team from NASA's Space Research Mission, Cassini, from 1997 to 2017, said, quote, "Saturn's F-ring is perhaps the most unusual and dynamic in the solar system. It has multiple structures with features changing on a variety of timescales from hours to years." So what inevitably led you to do your dissertation on Saturn's F-ring, and what did you gain from this experience?
Wow. That's an excellent question. So the work that I trained to do as a graduate student was to do numerical modeling. But numerical modeling is much better when you actually have real data to test your models against.
Mm-hmm.
And so what I had done was to create a model. In fact, I was one of the first grad students at Cornell to use a supercomputer, because they had just opened a supercomputer center there. And so I had these big models of all of these particles interacting, and we had the shepherd moons, and we're trying to understand, were they flat? Was there any kind of any height profile
Sure.
to them? What happens if something got perturbed?
Okay.
And I was doing that. I had a predecessor in grad school who had built some image processing software. And this is part of where I get that lead into the digital imaging stuff that I do later on.
Right.
And the Voyager data, which was all we had at that point, so this was back in the late 80s before Cassini flew, hadn't been examined.
Okay.
So I spent quite a bit of time working with a bunch of the Voyager images and actually doing using a technique called Fourier analysis.
Okay.
And that's simply a way to look for patterns in the data.
Sure.
And what we would expect if there are these embedded moonlets is that they have a regular impact, right? As they're orbiting, there's something that's happening every orbit or twice every orbit.
Right.
And so this Fourier analysis lets you pull that out. And that's where I found the evidence that there could be large embedded moonlets in the F-ring. But I absolutely agree with that quote that you gave. And the more that we've studied the F-ring, the more interesting it's become.
Absolutely.
And sadly, I haven't worked at all with the Cassini data. So this is not stuff I've done lately, but I can only imagine as we get higher and higher resolution, there are more and more. I mean, that's the great part about science and technology, right? One
it's a
answer,
symbiotic relationship.
A whole bunch of new questions.
Yeah, absolutely.
And a whole bunch of new investigations.
Yeah. So like you just said, I mean, agreeing with that quote, it's understanding Saturn's F-ring is quite unusual. And what I came to understand, and one thing I want to ask you, are there explanations for why Saturn's F-ring I guess, changes timescales from hours to years.
Yeah, it's the presence of both those shepherd moons that we talked about, Prometheus and Pandora, and then the stuff that's embedded.
Okay.
And so that it's essentially what you, I'm not sure how apt an analogy is, but I'll use it. It's like a three-ring circus going on in that ring where there are a lot of
Okay.
performers and they're interacting in different ways, and those interactions lead to different behavior.
Sure. So me trying to also understand it changing timescales from hours to years, how do they, or how do, I guess, and did researchers and scientists understand how it changed timescales?
So what they have are a set of images of the F ring that the space. So what Cassini did is it actually orbited Saturn for a number of years.
Okay.
And so it took a lot of data, both of Saturn, of Saturn's rings, and of Saturn's moons, which
Right.
and all three of those things are interesting in their own way.
Yeah.
And so what you have are essentially, some rapid fire click, click, click kinds of
Okay.
imagery. And then you come back a year later and you take the same image.
Gotcha.
And so it's that collection of things that you can start to say, okay, well, this didn't change in 5 minutes, but it changed in 265 days.
Hmm.
Year at Saturn is different, but in an orbit.
Gotcha. So all the conversions within that. So understanding through pictures, through visual and different imaging things, understanding that Saturn's rings are inevitably changing, and then some aspects of them aren't changing.
Yep.
Okay, understood. So I guess like the question occurs to me, in all due respect, why is this Saturn F ring research relevant? And so a question I do want to ask you as well is, what evidence from imaging and simulation research on Saturn's F ring is necessary for understanding early stages of planet formation?
So one of the things that we're really curious about is how do solar systems form? How did we come to be here? Right.
Mm-hmm.
That is the human question, and we ask it in a bunch of different ways. We ask it biologically, we ask it theologically, and we also ask it astronomically.
Right.
And so one of the things that we think is that planetary rings can serve as models for the way planets form, because you have a large central body, Saturn, rather than the sun.
Mm-hmm.
You have a bunch of material orbiting around it. And our theory of how our planets formed is there was a bunch of dust and ice that came together in small bodies called planetesimals.
Mm-hmm.
And then over time, some of these planetesimals got a little bit bigger, and then they got a little bit bigger and a little bit bigger. It's like the kid at the table that gets all the food.
Sure.
And they start to become the cores of our planets.
Okay.
And so now one of the really cool things about astronomy in the last 10 or 15 years is our telescopes have gotten so much better, and we can start to see this happening in other parts
Gotcha.
of our galaxy. And so we can test out some of our theories by actually having more evidence. And what we've discovered is we got some things right, and there's some things that don't actually line up very well with
Sure.
reality.
Sure.
I will have to tell you, this is not an area that I've worked in recently, so
Right.
I'm probably not the best guy to tell you the latest and greatest, but I do keep an eye on it.
No,
And
absolutely.
it's absolutely fascinating. And it leads back to, why we do any kind of basic science is it's driven by curiosity.
Mm-hmm.
That most human of characteristics that drives us. And in some instances, that curiosity is not going to lead to a new product or
Mm-hmm.
necessarily something that's going to improve people's day-to-day lives. But we put value in understanding why we're here, how we got here, and how others might have gotten in a similar spot. One of the great unanswered questions is there other intelligent life in the universe?
Yeah. No, absolutely.
Well, okay, then, one theory would say, okay, well, if it's like us, then what was our evolutionary path? How did we get from, gas and dust to you and I talking
Right.
on a podcast?
Right. Yeah.
And then, well, can we find other places in the galaxy where that, conditions are similar?
To occupy life. Yeah,
Yeah.
absolutely. And I love your point where it's just such the human tendency to just have questions. And these incredible people like yourself are trying to understand these larger questions. And despite potential failure, right? Failure within any line of work, you're not going to find those breakthroughs. But when those breakthroughs do occur, it's so huge. And so just to go back a bit and increase my understanding and for the audience as well. So like Saturn's F ring, it's argued that there's been a rotation of rings before in which debris and ice have created the formation of Jupiter, Saturn, Mars, etc.
And their moons.
Okay.
Yeah.
Okay.
And by the way, I don't like failure as a word. I think
Okay.
too many people turn that into something that becomes an anchor or a ball and chain for them.
Sure.
I prefer to think about it as I just found a way that it didn't work.
Right.
So let me keep working and see if I can find out a way that it does work.
Exactly. No, your perception. So you're saying like your perception on the word failure, you would just not use the word failure
Yeah.
at all.
I mean, why do we do that to ourselves?
Yeah, exactly.
I mean, Edison's probably the most famous for talking about all the ways not to invent the light bulb.
Mm-hmm.
But it's the same idea, and it feels to me like we put limits on ourselves that we don't need and that aren't helpful, particularly in a educational context.
Yeah, I think that's an incredible point. And just understanding, like you said, and for me personally, the perception of failures, it shouldn't be looked on as a barrier or a wall of some sorts. It should be looked upon as necessary for improvement, because in order to understand the world and what we're necessarily doing, we're going to make mistakes, but we don't stop there when those mistakes do occur.
And I don't know about you, but certainly for me personally and the people that I work with, it is pretty rare that we do things right the first time.
Right.
The first time is we're trying to figure it out, and then we discover all of the stuff we should have thought about, and then we do think about it, and we come to a better solution.
Yeah. Another thing that occurred in my mind was like hindsight's 2020, but it's also like you can't go backwards, and everything is a process of trial and error. You need to do things and learn from it in order to inevitably improve, right? This is leading into a great discussion. I'm loving this. But definitely switching gears a bit from the Saturn F ring conversation and things of that nature. So how do visualization, and 3D modeling programs facilitate better learning and understanding of science and mathematics subjects?
So that's a great question, and that'll let me share some of the interesting results that we've had from the geospatial semester. So the idea is that, to maybe put it at its most simple, is picture's worth 1,000 words. That we humans are inherently visual, right? We take in a lot of information through our eyes. And as a consequence, if we can develop ways to help understand the world that relies on those senses, then that might be an advantage. And it sometimes lets us do things that we can't do in words, or we can't do easily in words. Right. So, for instance, I could show you a map of the last presidential election results, and you'd get in a matter of a second or two a real clear sense of the voting pattern just by looking at which states are red and which states are blue. Right? That this is a common map that everyone knows. Imagine trying to describe that, and how many words you would have to use to paint that picture for someone.
Sure.
And so if you imagine then that you can use, and it's not just maps, but graphs and charts. I mean, there are all kinds of visualization tools that we use, but there are ways where we can convey a lot of data in a short amount of time. There are also storytelling tools. And I think one thing that people forget is that maps have points of view. Maps are not objective. Right. Someone made that map. They made that map for a purpose. That purpose might have been just to convey some information, in which case, it's reasonably objective. That map might have been made to convince you of something, like we really should put a new development here.
Right.
Or, global warming's not a thing. Or whatever it is. And so part of what we, as educated citizens, we need to have some literacy about visualization so that we don't get fooled,
Right.
right? So that we can ask the right kinds of questions and we can pick out when someone's trying to sell us. Now,
Sure.
you're welcome to be sold, but just do it with your eyes open and not, all of a sudden discover, hey, wait a minute, right?
Yeah. No, absolutely.
So the one thing that we've done with the geospatial semester, the high school
Mm-hmm.
program, is that we saw that really interesting stuff was going on. And this has been true with a lot of people that have done research on the use of GIS in education. But what nobody had was evidence.
Right.
That's overstating it. There wasn't much evidence. There were a lot
Okay.
of stories, and there were great stories. And in fact, I would tell a bunch of those stories.
Right.
But what we decided is we really needed to actually do some research and see what we could determine, what we could
Sure.
demonstrate about what's going on. And so the really cool thing is the students that take the GIS class in high school,
Mm-hmm.
when you compare them to their peers that are similar but didn't take that class, we see that the kids that took the GIS class have better spatial language. It's probably not super surprising because they're talking about some things that
Mm-hmm.
they wouldn't normally. They also have better scientific problem solving skills.
Hmm.
They're better at arguing with evidence. They're better at drawing inferences.
Sure.
And the really cool thing we did, so this work was all work that I did in partnership with a guy named David Utall at Northwestern,
Okay.
and a cast of characters over the last 10 or 15 years that now numbers in the dozens.
Right.
But we connected with a researcher at Georgetown named Adam Green, and we take a subset of the kids to Georgetown and we scan their brains in what's called an fMRI, a functional MRI machine.
Mm-hmm.
And we actually have evidence that shows different connectivity patterns in the brains of the kids that learn GIS versus the ones that didn't.
Interesting.
And them recruiting different parts of their brain to do problem solving.
Okay.
And so what we're discovering is that, and it's not, this is, you tell a psychologist this and they'll say, well, yeah, duh.
Mm-hmm.
If you
Knew this all
are,
along.
if you are using visualizations, you're recruiting different parts of your brain to
Right.
do some of the problem solving.
Activities
and so you're
and
going to
yeah.
see different connection patterns, and you're going to
Sure.
see people be able to interpret these data in different ways.
Sure. Just to go backwards a bit and address and acknowledge what you said. Well, one, visualization is so important. The ability to use your eyes and understand data. And then obviously, like you just said, which also shifts my perspective a bit, is knowing that or understanding that maps aren't necessarily objective. Who did that map? Who created that map? And what was their perspective and what idea and story are they trying to portray? Like you said, if an individual wants to make a map and they have the perspective that climate change isn't necessarily a thing, they're going to create a map in which it's going to portray that. But my question would be is, would you argue that visualization and maps decreased the needing of using more words? Like if you show a map, do you feel as if someone can understand that they need to use less words to explain that?
Sometimes. Visualizations are a powerful tool that can be used as a part of either a quest for understanding or to try and make decisions, but you absolutely have to be able to talk about them, and you need to be
Sure.
able to reason with folks, to argue in the positive sense, not in the the pejorative sense, and you need to come to common understandings, and that's only done through language. You can't. It's really hard to come through to a common understanding between you and I, say,
Sure.
I just put a map. Now, we could talk about and agree on what we've seen or agree on the course of action that we might want to take based on what this map has shown us. But the human interaction is a critical element to this. And
Right.
this is not technology in replacement of humans.
Right.
This is a
No.
technology supplement for humans.
Sure. But why is technology so crucial in this context? So viewing, molecules and formulas, et cetera, because I know you did work in regards of, visuals and modeling for understanding chemistry or mathematics and things of that nature.
So one of the reasons that it's important is the visualizations let us access huge amounts of data. So if you
Hmm.
think, we talked before about the satellite images, the
Right.
Google Earth style pieces, those images are hundreds, if not thousands of megabytes to have the level of resolution that you can zoom in and see the mirror on your car.
Right.
And so as a consequence, without that, without the technology, we simply wouldn't have the ability to interpret those data, to classify them, to actually even necessarily develop models. And so
Sure.
with the technology, again, a crude analogy, the technology is our glasses here.
Yeah.
If I take these off, I'm in trouble.
Hmm.
But with them on, I can make sense of the world in front of me.
Right.
And for me, I see GIS in a similar light. It, it it opens doors and windows for us
Hmm.
and provides us access to things that we simply wouldn't be able to. I mean, our brains would have a hard time wrapping themselves around 1 billion pixels.
Sure.
I
Sure.
mean, if you didn't have technology, well, one, how are you going to take the image? But two, how are you possibly going to make sense of it?
Right. And understand it. And I love your point as well, where it's humans are the ones making this technology and making sense of it, but also technology should be used as an extension. It shouldn't be used as something of, I don't want to sum it up as takeover, but in some way, shape, or form, um, removing the human aspect out of the equation is, I guess, how
Yeah.
I phrase it.
Ultimately, people use GIS to support decision making,
Hmm.
and it's you and I that need to make the decisions. We can be informed by the technology, we can be informed by AI, but at the end of the day, the expectation is someone's going to be responsible for making a decision and taking action, and that's us, right?
Sure.
That's not the computer.
With technology rapidly improving and evolving in short order, how will this impact, uh, and how education will be conducted?
Oh, you've asked a really interesting question, especially as AI seems to be at the front of so much of what we're doing. And in fact, JMU has just formed an AI task force
Oh,
where we're
wow.
really looking at the impacts of AI across campus and student work and faculty work and how we actually run the university. And so we're all wondering about this. I think from my perspective, what technology offers is a way to customize education. So, remember back to your time at JMU, you were one of 30 or 50 students in a class, and you said you were a finance major, right?
Yes, sir.
So you're in a finance class, and it might be that 80% of the class understood a concept. You might have been lucky to be part of that 80%,
Hmm.
and you're
I'd
smiling
also,
at me, so you're thinking of an experience where that you might have been in the 20%
uh,
where
oh, hey, absolutely. It's definitely been plenty of times, I would say.
I, and so, but as an instructor in front of 50 people, it's really hard to be able to pull that out. And then how do you work with the 80% that are ready to move on?
Sure.
And yet there's 20% that aren't. And if there were an adaptive system that was available either in concert with the instructor or separately, where it would be able to tell what you know and where you're struggling and then
Hmm.
give you the supplemental instruction that you need, that's kind of interesting.
Very
Like,
important as well.
it's customized to you in some really interesting ways. And I think AI offers us some inroads there. Now, there are some real challenges. I think these large language models, the generative AI, ChatGPT, and the like.
Hmm.
Um, what we do know is students around the world are using it,
Hmm.
and they've discovered that you can put some stuff into the AI, and what it generates is actually pretty decent quality for a lot
Outsource
of
their
folks.
work. Yeah.
And so, given that we, in many ways, at least in the American educational system, we use writing as a way to teach reasoning,
Hmm.
right? As you learn to write, you learn to make arguments and you learn
Hmm.
to support arguments, and you do that both orally, but often you do it in writing.
Sure.
And if we now have a technology that will do that for you, it really makes you stop and think a little bit about how we're going to teach writing, what that's going to mean.
Sure.
For me, Lucas, I was in school when calculators became a thing.
Right.
There was a time before calculators. And I remember these questions about, well, no one's going to know any math.
Yeah. Right.
And that's not been the case. But what is the case is that the math that you learned in school is not the exact same math I learned in school.
A little different.
I'm going to bet you haven't done a lot of long division in your life.
Most likely not. No.
Yeah. And you're doing just fine.
Appreciate it.
And I did a fair bit of long division in my life, and I've had little occasion to use it.
Mm-hmm.
So it really opens up this interesting time to think about writing in a similar way to how we had to think about math when the calculators came in.
Mm-hmm.
And I don't know what the right answer is, but what I do know is that when technologies are available, people will use them.
Sure.
And so how can we help people use them thoughtfully, use them in a way that supports their learning, uses them, in a constructive way? And that's some of the conversation we're starting to have at JMU.
Absolutely. So with the conversation you kind of just presented, it creates almost a two-folded question that I'll try to combine, in which the importance of writing and doing those, manual tasks are, I mean, it's incalculable how important those are, and the conversation of potentially losing that is very much within the horizon. And so combining that with, do you feel as if it's beneficial for educators, teachers, administrators, deans, etc., within colleges, universities, and high school, middle school, and the like? Should they embrace these large language models? Should they embrace this artificial intelligence in order to facilitate better education, I should say? Or do you feel as if it truly just jeopardizes the process? And I know that was a very lofty question.
It's I think from the way I see it, I think that's a false binary. I don't think it's an either or.
Okay.
I think we have to interrogate the technologies. We're going to have to do some experiments to understand what it means to teach writing to elementary school students and middle school students in a time where they have ChatGPT, in the same way that we've really had to think about how we seek out information in a time of Google. I learned a whole set of skills when I was in high school, long before when the dinosaurs ruled the internet.
Don't say that.
That are useless today. That's not how we seek out information anymore. So I think what we're going to see is an evolution. And what often happens, particularly in the beginning of an evolutionary period, is it's kind of rocky because we bring a bunch from the past. I mean, the past is a backpack that's loaded onto our back, and at some point we decide it's too heavy.
Yeah,
but it takes a little bit. And so I think, and one of the things that we really have to pay attention to is the large language models come from scraping the internet. The internet, there's a lot of good on the internet, but there's a lot of bad on the internet.
Absolutely. Yep.
And so some of the biases and some of the prejudices that are on the internet, we have to be really careful they don't get baked in to the large language models and then continue.
Very true.
That we've seen. And so thankfully there are a bunch of people paying attention to this. But I think it's going to be very much an evolutionary process. We're going to stub our toes along the way.
Right.
We're talking at JMU right now, and we don't yet have a university policy. So faculty members are kind of working it out with their students about how much ChatGPT or the other tools are permissible.
Sure.
We don't have good tools to say, oh yeah, that was written by an AI. So we're in a kind of twilight,
like bit of gray area,
dawn sort of period. It's not all clear to us how this is going to go, but the possibilities that the technology afford really energize a lot of the discussion, and I think that's ultimately going to carry us forward. Right? No technology is inherently good or evil.
Sure.
It's the uses to which we put it.
Exactly.
And I think we need to figure out what uses, educational uses, the large language models are best suited for, and then take advantage of them. And then we
Right.
can get into that adaptive learning that we talked
Sure.
about just a few
Sure.
minutes ago with
Sure.
the example from your finance class. Because we don't have enough teachers, right? There is
Right.
not enough human hours in the day to provide that level of personal attention to learners.
Hmm.
If we can supplement that, why wouldn't we do that?
Exactly. Exactly. In a conversation for hopefully a later discussion in which you talk about the potential, narratives that one might have within that is embedded in, like you said, baked into these large language models is something to be aware of. And so just switching gears, because I do want to address this question for the last little bit that we have. So in your work, you shed light on the importance of United Nations Sustainable Development Goals, which you describe as a blueprint to sustain our environment and well-being in its relation to spatial thinking, reasoning, and geospatial technology. Um, Within the time that we have, just a short bit, you can go whatever way you'd like. Could you provide a brief synopsis of this publication while touching on the importance of geospatial thinking and technology in this context?
You bet. So one of the challenges for us as citizens of the planet, not just citizens of the U.S., but citizens of the planet, is how we preserve and sustain our world. And the UN has developed this framework called the Sustainable Development Goals that offers a pathway to think about what every inhabitant of Earth needs, from clean water to food supply, to rights for women and men,
Mm-hmm.
boys and girls, and folks that are transitioning and non-binary. And so we've really focused on trying to identify which of those things, and we do this in our college. Our college is really focused on sustainability and resilience, and we're trying to identify those goals where we can really help students make a difference in the world.
Mm-hmm.
And so many of those are geographically based, right? They have to do with where you are on the planet, what the situation is on your part of the planet. Well,
Right.
what about the different parts of the planet? Our planet's one organism. How do all those pieces intermingle? How do
Sure.
they connect? And so I personally see geospatial technologies as one, not the only one, but one of the key tools to let us make sense of this really, really
Right.
complicated system. And I think that's the real, that's kind of my message of opportunity here, is it's a way of thinking that complements so many of the other ways of thinking, and it needs to be part of the mix as we're trying to figure out how we're going to persist as a species and how we're
Absolutely.
going to continue to have a quality of life that we all enjoy on the planet.
Absolutely. I mean, you concluded that perfectly, and you already answered my question, because my next question was going to be kind of what steps can humankind take to understand our world and these particular trends that are happening absolutely everywhere. So you feel as if, geospatial tools and technology is very helpful for understanding that.
I do.
Yeah,
I do
absolutely.
indeed. Yeah, more
Awesome.
GIS for everybody.
Beautiful. Beautiful. Dr. Kolvoord, well, thank you so much for coming on to the Common Human podcast, and I very much appreciated your time.
Thanks, Lucas. I enjoyed the conversation.